So I'm Hamil Shah. I'm a CEO and director of Brilliance Solutions, a company who focuses on professional security services on the application front. So we are based in India, a western part of India, and we only do an application security. So some of the key points in my today's talk is, let's understand what everybody is talking about: DASH, SAST, IAST, RASP, and everything. But let's understand what value or what additional value a human can bring into the when it comes to the application security. Then I will be walking you guys through a few unique cases where a vulnerability can be only identified by the humans and not any automated tools. We will be also looking at the methodologies for some of the modern world application and the architecture of the modern world applications. And then at the end, I'll be also suggesting some of the key approaches on how to mitigate or how to protect against these vulnerabilities. So let's start with this demo where, oops, just a minute, I think some technical glitch here. The demo is not shown there. Sorry, I think, okay. Probably have to do this manually, so. So if you look at this demo, this is a typical DVD store which allows you to buy and sell the DVDs. And when you do the checkout, it actually asks you the name, address, and all the details which typical e-commerce application will do. And when you look at the source code of this, I realize that there is actually an order number which is sent from a client side to the server side. And when I submit the order, it shows me the confirmation that the order has been submitted. Now, if I do a refresh, it gives me an error that the order already exists. So when I try to resubmit the same order, the application gave me an error message, and the error message had the complete path of the directory where the order has been stored. So if I try that orders directory, it's actually a browsable directory, and I can pretty much see all the orders which other customers have submitted. And now what I'm going to do is, so if you test this using an automated scanner, the automated scanner will give you two vulnerabilities in this case. The first one is the browsable directory, which the orders directory is a browsable directory. And the second one would be that the order number is actually sent from a client side to the server side. And that's all. The automated scanner doesn't have the mind like a human to find out what other vulnerabilities can be possible here. So what I can do in this case is I can actually inject a code. So I'm going to write an ASP code here, as the application is actually running in ASP. I have this code which allows you to do a command execution on the server. So I will paste this code into one of the text field, and then when I submit this, it actually, as the order number was actually sent from a client to the server, I can now create a file which is test.asp on the server. And then when I submit this order, boom. And then I go back to the orders directory. There is a test.asp page. And from here, I can run any OS command. So for the human, what has happened in this case is So for the human, it's actually two medium vulnerability. But a combination of both vulnerability ended up resulting into the one very critical vulnerability which can sacrifice your server. So a typical vulnerability on how the automated scanner works is that it will try, as you can see in the first screen or first snapshot, that the attacker will try these exploits and it tries to find the bug. That's how the automated scanner will work. But for humans, they can correlate multiple vulnerabilities to find out the more critical vulnerabilities. So if you look at some of the history from 2010, so this is a stat from GFI Landguard, where more of, if you look at the trend of vulnerabilities, the trend is actually moving from an operating system or a network layer to the application layer. So by 2014, more than 83% of the total vulnerabilities discovered were actually at the application layer, compared to the 13% at the OS level and then pretty much 4% at the network layer. So pretty much the trend is moving from the network or an operating system layer to the application security now. If you look at some of the recent past attacks just in 2015, there were like 11 million records were stolen, 80 million records were stolen, and so on. So the number of records which are stolen by the application attacks are tremendous. If you look at the TrustWave reports in 2015, as per them, 98% of the applications have some kind of a vulnerability. And an average vulnerability per application is actually 20, which has rose from 13 to 20 in just 2 years. 95% of the mobile applications were vulnerable, and average vulnerability in the mobile applications were 6 to 7. And out of those, 35% of the vulnerabilities were really critical and 45% were very high risk issues. Now, this is an industry standards, but when we at BlueInfi does the testing using a manual or a human intelligence, the numbers are quite different. Around like 85% of the application we find authentication or an authorization bypasses, where vulnerable version of underlying frameworks we pretty much find in like 97-95% of the application. Authentication bypass is found in almost like 90% of the application, and XSS and injections are pretty much every other application has an XSS these days. And the injections are declining, where 60 to 65% of the applications where we find an injections. So if we do some post-mortem, 98% of the applications are vulnerable. Web application layer vulnerabilities are growing at rapid rates. Client-side hacking and vulnerabilities are on the rise in recent past. Now the focus has been a lot on the web, on the client-side attacks as well. So if you look at the technology trend, what has happened over a period of time is that from 1993, the World Wide Web started, and when we then there were a CGI pages introduced, and then there was an scripted pages like an ASP, JSP came into the picture, and then application framework like Struts and .NET came into the picture, and then Web 2.0 era came in like around 2008, 2009 time, and now we are all talking about HTML5, HTTP 2.0, and mobile applications and SOA architecture and everything. So the challenge with the developers is today's development life cycle is very rapid and agile development is happening everywhere. Catching up with new technologies for the developer is never easy. They need to start learning the new technology like Web 2.0, HTML5, HTTP 2.0, and so on. They have to also match and tight deadlines. Very frequent release cycles. Last year, Facebook had like more than 500 releases in a year for their iOS. The business requirement has been changing, and then on top of it, security professionals are throwing in security requirements, so they have to worry about everything and still produce a secure code, which is really a challenging for them. If you look at the architecture perspective, before this HTML5 came into the picture, pretty much all the professionals or all the developers had agreed that their presentation layer, the business logic, and everything needs to be, only the presentation layer needs to be on the client side, and then all other layers needs to be on the server side. But but with HTML5, now the browser provides a lot of features like IndexedDB and local storage and all that. So a lot from other than the presentation layer has been shifted to the client side as well. Lately, we have been seeing a lot of complex structures like Node.js, Mashup, browser extensions, NTD framework, JSON, GWT, WebSockets, AMF. On the database front, we are now seeing a lot of MongoDB and Hadoop and IndexedDB and file APIs have been used. On the client side, AngularJS, HTML5, Express.js and Knockout.js is mainly used. So this is in my slide from probably like 5 years back, where at different SDLC stages, we need to have a different controls, or the security needs to be implemented at each phases of SDLC. But really the question is it enough, or are we doing it right? Even if we are doing everything where we have a secure coding training and secure coding guideline, a source code review, a penetration testing, and still there are applications which are produced which have multiple vulnerabilities out there. So the question really is, if you look at it from the methodology perspective, on the black box, so on the left there is a black box, and then on the right hand side there is a white box methodology, where the asset has been tested on the black box front by footprinting and discovery, and then enumeration and attack and scanning. So typically a automated application penetration testing tool will crawl the site and then try to fuzz each and every parameter. So your automated scanner is as good as it can crawl the site. But now the challenge with this automated scanner is that there is a lot of JavaScript which has been used. So they cannot even find the asset which are created, or which URL has been created using a JavaScript. On the source code review front, the biggest challenge with the source code is it generates so many false positives that you actually end up eliminating actual vulnerability, or removing an actual vulnerability while removing the false positives from the source code. So in the black box, what is missing is the correlationship between the vulnerabilities, where in the white box, the exploit on the deployment testing on the testing using an actual exploits, and the deployment testing has been missing. So there is no proven automated scanner which actually gives you the perfect results. So the black box method uses crawling, as I said. Application assets are now residing using the JavaScript and various other tags in HTML, which is very hard to find by the automated scanner. And the white box, the false positive has been the biggest challenge. If you look at the modern applications, they have the challenge with the scanners is that how to identify possible hosts running the application. So how do you determine that the calls are actually made for using a cross domain? Or how to identify the AJAX calls and HTML5 calls, or the dynamic DOM manipulation, or XSS and XSRF vulnerabilities of Web 2.0, or even the DOM-based XSS is very hard to find by any automated scanners. So game is really getting very complex when it comes to the application security. So now let's look at some of the vulnerabilities which can only be identified by the humans. The first one is my favorite, where a lot of security professionals will say that you use a server-side session variables and keep on storing the information in server-side session variables before you actually perform the transactions. What I'm actually doing in this attack scenario is I am attacking a server-side session variables. So so this kind of a vulnerability is typically found in a wizard-based application, or a functionality which is a multi-step functionality. What I'm going to do, so typically, and what an application does is they keep on storing the information on the server-side variable. So on the first step, they will store whatever the information you store, the user enters on the server-side variable. On the second step, they will append the value. On the third step, they will append another value. And on the fourth step, they will confirm and let the attacker do the transaction. So, if you look at this demo of and currency transfer, oops. So this is an application which allows a user. So not sure about the Europe, but a lot of banks in US as well as the Middle East allows you to have multiple currency accounts, and then you can transfer a current amount from your first currency account to another currency account, right? I think even in Europe you can have you can transfer a fund from your account to another user's account, right? Now, what I'm going to do in this account, so this is an example where I have a multiple currency account. So I go to transfer, and then I select that I want to transfer my dirhams into my Indian rupees account, and then it shows me the rate that of $1 is 65.18 Indian rupees, and 1 dirham is 18.09 Indian rupees. So I'm going to transfer this dirham into the Indian rupees. So this is a multi-step. So as soon as I entered the dirham to Indian rupees, the server actually stored the two currency names on the server-side session variable. Now if I select 1000, so I want to transfer 1000 dirham into the Indian rupees. So it confirms that you want to actually transfer 1000 dirham into the Indian rupees. So this was a second step. So now on the first step, we had the dirham to Indian rupees. On the second step, application stored the amount which I wanted to transfer. Now, if I click finish, it shows me that it has transferred 1000 dirham to Indian rupees, and the amount which I got credited was 18,090 Indian rupees. Right? So this is a normal transaction which any bank will allow. Go back to the slides. So on the first step, the server-side session variable was created and it stored the two currency, and on the third step, the amount, and on the fourth step, it confirmed with me that this is what the amount which has been transferred, and on the fifth step, it actually transferred the currency. Can anybody see the attack scenario in this case?
Switching the currency with some different ways.
Sorry?
Going back, switching the currency with some different ways.
If you go back, then when you press next, the server-side session variable is going to be overwritten. Okay, so let's look at another demo where what I'm going to do is, sorry about this challenge actually. So I'm on the same application. I'm going to go back to the transfer, select dirham to Indian rupees. Right? So now think about this, what has happened on the server-side session variables. It has stored two currency from and currency to. Now I'm going to enter 1000 and go to the next. I stop here, right? I open, so it shows me that the final amount, so now the server-side session variable has three values. Currency from has a dirham, currency to has Indian rupees, and then amount is 1000. So I open the same application in a new tab and go to the transfer. So now remember, my server-side session variable still has those three values. Now in place of dirham, I select US dollar, and then I keep the same amount. It shows me the same message. Then I go back to the first tab. So now what my currency, what my server-side session variable has is, it has the currency from is US dollar, currency 2 is Indian rupees, and the amount is 1,000. Now if I go back, close this tab, and click on finish, what's going to happen? It is actually going to debit my 1,000 dirham and give me the 65,000 Indian rupees, which is equivalent to what my US dollar would be. So if you look at the steps in this case, is what I did is I added one additional step in this case. So earlier it was a 5-step process. On this case, what I did is I had a 6-step process. After completion of a 3rd step, I moved to another tab of a same browser, so I don't have to provide the cookie and everything. And then I overwritten the server-side session value of a variable stored on the server side, and then closed that tab and came back and completed my transaction. The next vulnerability is bypassing authorization bypass by modifying the responses. So historically, all these automated scanners has been only fuzzing the request. But as we saw that a lot has been changed these days, and for a faster updation of an application, of what has been done by the developer is they put all the codes on the client side, and then based on the parameters or based on the response from the server side, they will load a different UI. So it pretty much becomes very important to fuzz the response these days as well. So there has been I would say around 5 out of every 50 applications, we discover the vulnerabilities by modifying the responses rather than the requests these days. As the browsers are providing this capability of storing the information on the client side, the web developers are using it. But then, as a result, some of the business logic has been transferred to the client side. So if you look at this demo, going back to the demo, what I'm going to do in this case is, again, the same application. Sorry? Oh, sorry. Got to cancel it. Okay, thank you. So again, the same application where I'm logging into the application with my partner's name Sriraj, and then there is a flag which came. I think let's see it. Start it again. So when you log into the application, in the response, you see the flag. Dealer came back, and look at the number of menu items shown to the dealer. It's actually 6 different menu items which are shown to the dealer. Now, there are 6 different menu items in this case. Now, I log out of the application, or I click on any menu items, and then I take this response forward, and then there is a value called user which came back. Now, if I change the value of this user to dealer, let's see what's going to happen. I change this value to the dealer and then forward this response. Now if we go back to the application, there are 7 different menu items. So the additional menu news which is opened up for the dealer in this case. So by modifying the response, you can open up an entire new functionality of the application. The HTML5. So before HTML5 came into the picture, the XSS was really becoming pain for us because everybody was using HTTP only flag to protect against XSS. So even if you find an XSS, it was pretty tough for us to get an access to the session cookie. Thanks to HTML5 and thanks to browsers, this has been opened up. Now, a lot of HTML5 tags allows us to access the cookie even if the HTTP only flag is enabled. Or a lot of time developers are storing sensitive information onto the local storage, or the cookie are actually stored on the local storage of the browser. Also the account lockout. There has been a lot of instances where the number of failed bad attempts has been stored on the client side cookie or client side storage. So if you look at this example, sorry, I have to cancel that first. In this example, the cookies are actually storing the bad attempts. Now, if you look at the value of this, as I enter the bad passwords, it keeps on changing the values. So now, if I want to run a brute forcing tool against this, all I have to do is add an additional layer into my brute force, or add an additional script into my brute forcing tool to reset this counter to 0. Or even easier, I can set it to minus infinite number, and then it will keep on adding. And I can still run a brute forcing against this kind of a functionality. So it's really important on how you are storing the information on the client side and what information is stored actually. A file upload, another favorite attack of mine, where a lot of application doesn't validate what has been stored on the server side or where the information has been stored. As we saw on the first demo, where it was pretty easy to run a command execute. It was pretty easy to execute a command using an upload functionality. If you test a file upload functionality with any automated scanner, they will give you one informative finding that a file upload functionality exists. But now, let's see what a file upload, what an attacker can actually do using a file upload functionality. So I log into the application, and then application has a functionality which allows me to do a bulk upload of the file. I uploaded an ASPX code because the application is written in ASPX. And when I upload this function, it shows me where the files are stored. And then I can view those records. This is a very typical functionality. If I go back to another tab and start running the commands, I can pretty much execute any command using this script. So again, the automated scanner will just give you a one low or an informative finding where a human can actually execute command on the server. The next one, the SQL injection. How many of you have actually found a SQL injection in a parameter name? So most of these modern world automated scanners will only try to fuzz the parameter value. Now lately, there has been a lot of instances where the injections has been discovered into the name rather than the value. So let's look at that example demo as well, where so there is a search functionality in this application which allows you to search the different stocks, and I can search the price of the stock and get a results here, right? Now if I copy this URL and paste it into the another tab, and then as a typical penetration tester, I will try all single quote, double quote and everything into the parameter value. Wait for delay to find out if there isn't blind SQL injections. Nothing works for me. So now what I will do is I will try the same attack vector into the attack name, and boom, it worked. So it pretty much becomes very important to fuzz the parameter name along with the parameter value as well. Third-party posting, injections, and streaming. So a lot. There has been, I would say, around like 2 out of every 10 applications where the information is sent to the third party, like Google Analytics, to see what the user's behavior is, right? And especially in the mobile applications, this is very common. Now, when you actually implement that, it is very important that you also identify or you also verify what information you have been sending. Actually, I think I moved to the next slide. This is another attack. So I'll come back to that attack once that slide comes in. Third-party posting and injection. So if you look at the architecture of a modern world applications, your application has pretty much become like a landing page, and then it is fetching an information from another sites and then just displaying it. Like there are plenty of sites which does it, because if I am a user, every morning I wake up, what I do is I check my news, I check my emails, I check my Twitter account, my Facebook account, my bank account, and so on, right? So why would I go to all these sites and check my information? Rather than that, if I have a one site where I can just give my authorization, and then that site will give me all the information which I'm looking for, I would rather use that, right? Now, when you are providing such application, or when you are actually getting the data from any other third-party application, or even in terms of enterprises where you are consuming other web services, it becomes very important for the application to validate what data has came and perform both input validation as well as output encoding at the time of before displaying the data to the user. So if you look at this demo where my application has a widget, and so my application allows different widgets, and I'm actually reading in different RSS feeds from the different locations. And when I select this field, if application is not performing in proper validation, the XSS attack vector, which is not part of my website or my application, would get executed into my session. And then using an XSS attack vector, an attacker can actually steal the session of my application rather than the data, rather than the application from where I'm getting the data. So over here I have injected a sample XSS, and by exporting this, an attacker can actually get an access to the session of the application. Applications are asynchronous injections across critical functionality. So again, this happens a lot into the financial world application, and the application where everything doesn't needs to happen immediately, right? So again, an automated scanner will fail miserably in this case, because all the automated scanner can do is send a request, get a response, and see what has came back, analyze the response, and find the vulnerability. What a human can do, so in this example, let's say there is a batch which ships you all the statements in a bank. So if you have a bank account, you just enter your account number, and then there is a third-party batch or an asynchronous call or a web service call which will send you, which will run at like 10 p.m. in the night and will send you all the statements. Now, what if I find a SQL injection in this case? If I find a SQL injection in this case, pretty much I will get the statements of all the user accounts of that particular bank. Another example would be a custom protocol handling, where all the scanners can only identify the vulnerabilities on the HTTP protocol. If you are using any custom protocol, the automated scanner won't help. Information leakage via analytics calls. Lately, there have been a lot of instances where the developers implement the analytics cut across the application, and what happens as a result of that, even the sensitive functionality like your change password functionality or the forgot password functionality calls or the URLs will be sent to the analytics call as well. And as a result of that, somebody having an access to those analytics calls can actually get an access to all the users' information. So some guideline on how to protect against all these vulnerabilities is definitely an input validation on the server side is very key. Perform validation for type, size, length, and exception and expected characters. Implement defense in depth. So implement defense at all layers. Client-side validation is no validation at all. Sanitize all output or perform output encoding. Do not store any uploaded files into the web root, otherwise you're going to have a command execution on the server. Have proper permission on the directories where you're storing your uploaded files. So in a nutshell, humans can find what machines cannot. So humans are changeable. No matter what we do, humans are going to be the superior than the machines. Leverage combination of both human intelligence as well as the automated to achieve the maximum security to minimize the risk of your organization. Thank you.